So let me introduce myself. Yeah, I'm quite new in Samba world. I started in 2021 as Samba maintainer at Red Hat together with Andreas Schneider. And since last year, I'm a Samba team member as well. I would like to mention that in the past, I was working also with NFS. I was 6 years kernel engineer at Sun Microsystems, worked with Solaris, supporting NFS v3, NFS v4, doing mainly bug fixing for already released versions and also some small development. So what are winbind log files? I assume everyone knows, but just to start with. So in varlog Samba directory, we can file all Samba logs, and winbind related, there are few of them. The first one is for the main winbind process, which delegates asynchronous requests to all the children. Each of the child works with or communicates with the domain. And in the here we have some example how the trace looks like. It is a text file. It has a simple formatting. Each trace records start with something which we call debug header. Interesting field is the timestamp. We see also the lag level. In this case, it's number 3. We also the PID. It's the PID of the not of the winbind client, but of the process itself. And then there are some more information. Then follows the body of the trace records. Sometimes it's one line, sometimes it's many lines. So one of my first tasks at Red Hat was to improve the content of this text file. The reason was that customers were asking for better logging. And it was also a great task to start with because it allows me to learn new things while going through the whole winbind code. But during the work, I have realized there can be much more done than the initial request. So, and the ideas come one after the other. So instead of the initial first task, I have done 4 more. I will not go to the details at the moment. I will explain later. So, as I mentioned already, Red Hat customers were asking for improving of logging of async calls. Some functions were not logging at all, so someone was looking for some traces which he expected to be there, but there was just nothing. Then the log level was not consistent. Some functionality is traced at level 10, some 5, some 3. So this was make sure that it's consistent and at least the important functions were enhanced to trace also input and output data. Yeah, so as mentioned, there is example of the code changes. Winbind gets requests from the client. These are called as external command, and it's traced on the log level 3. This is a macro we use inside Samba for log level 3. We also see that always the input parameter, in this case it's a username for get pwnum call, is being traced. Then for the external command, we always trace also the finishing of it and also the output parameter. This is a different command, get DC name, and we print also the value. Internal commands are traced on log level 5, which corresponds to the info macro. And the amount of work it was 46 per file commits. This is not complete winbind code yet. Some functionality is missing. This will be done in the next step. For example, failover logging is one of them. It means when the winbind loses connection to the control and it reconnects to a backup control, the traces are not really nice at the moment. Yeah. So when I was reading the traces, I have realized that it's really difficult to understand sometimes how to interpret them. For example, here, there is example. It might look that we have a request for lookup name and a response for lookup name, and we can read user Joey has sit and dig up with RID 1107. And these traces just follow one each other. So that's something what I would expect. They are related, but actually not. So yeah, Joey 1107, and if we trigger winfo command and ask for the name to sit translation, we see that Joe is actually 1110, and it's Alice who has 1107. And there is no way to find this out. What happened, very likely, Alice was, if we would scroll up a little bit, we would see also the input lookup name for the Alice, and the response is just here, and the response for Joe will be probably somewhere here below. But we can't match it. There is no way how to match them. So what I have added, it's a new debug header field called traceid, and this is a unique identifier which is kept during the whole request processing. And moreover, this traceid is propagated to the child processes. So you will find if the request for Joe is sent to the winbind responsible for AD domain, it will use the same traceid 92, and you can follow the traces there. This work was based on already present T-event changes, which were done in 2021 by my colleague from the head, Pavel, who is working on SSSD. He was using it for tracing as well, and it was done together with Stefan Metzmacher. I just needed to extend it a little bit because I have found out that the initial T-event changes were not covering T-event queues, which is a feature which was not used by SSD, so they haven't realized that this unique identifier is not transferred if the request goes via a queue. Yeah. So once we have the trace ID available, we can just pick up only all the traces which share the trace ID, which is here. And now I would like to know what was actually the call flow, because the processing is winbind uses quite big nesting level. It means we have some initial command, it triggers some subcommand, and the subcommand can trigger another subcommand, it can trigger another subcommand, and nesting is really big. And for example, I would like to know this lookup sit start, who actually has triggered it. Was it this one, this one, this one, or this one? I don't know. The only answer is to open all these source files, look there, and see who was actually doing that. So to address this, I have added additional debugger field, and behind that there are new T-event changes which keep the information about nesting level in the T-event each request, and it's printed in the traces as well. So we see that this is at depth 2. That's expected. There is no other way, because the first one is the external one, and if it triggers something, it's for sure depth 2. This one is also on depth 2. It means it was not triggered from here, but for sure from here. Next one has depth 3, and this one has depth 4. So now we know what was the call flow here. But this is not immediately obvious, so I have decided to do one small improvement to the changes, and this is the indentation. You can see that every, not the header file, but not the header line, but the text itself is indented, and the indentation is 4 spaces for each nesting level. So then you have fast, nice visual view where what processing belongs to what. Yeah. Other thing is that the traces, even if you take for a single request, they can be even few thousand lines long, and you are missing the overall or some navigation. What was going on was how the code was, which path it was taking. So I have decided to do some more improvement, which I call flow tracing. There is another extension of the event library. It's not yet present, it's still work in progress. And it adds to the traces lines like this. It's a text line, it says flow, and it always, if a new event request is created, it logs the name of the function who called that. And there is also the step back once the request is finished, and it notifies the parent, hey, I'm finished, you can continue. Similar line is printed as well. And what I do, I just grab for all these lines and remove just the flow colon, and I will get something like this. So if we, for example, have the get pwnum command, I immediately have some idea what is the flow. And when analyzing some behavior, I could understand why I am at the moment, for example, doing this lookup set. Yeah. For example, I can easily distinguish that there are 2 lookup sets. I can see that one is done for the user probably. We see got UID. The other one is for the group, got group ID. And this I will open in one window, having navigation, and in the other I will open the full traces and try to understand what's going on there. Yeah, this these flow traces are on log level 20, so they are not always printed, only if we really want. Yeah, and the previous traces, they were a little bit shortened because we always, this is small on purpose. This is, I would say, maybe a quarter of one request. Processing, it's not able to show it completely, and it shows every single event request which is created during the processing of something. So we see that really the nesting level is big. There are some patterns which repeats. This is the part when the main winbind is communicating with the child winbind process, and this is almost always the same. So there is a way to decide just to remove this repeating pattern. And it's also when I was starting to get familiar with the code, this helped me a lot of. Because follow all these things if they are not traced. And it's also, yeah, if I was in a debugger somewhere in here, which was at this time maybe manual, there are some code here is auto-generated, some is manually written, and sometimes it's difficult to understand why I'm just here and not there, and this helps sort of. Yeah. And the last step was to create a tool which will help to extract the data from the traces which contain everything. So the name of the tool is Samba trace parser, and we can ask it to give me all trace logs for specific winbind client process ID, or we can just, which will be translated to a set of trace IDs, or we can want only to see a particular trace ID. Or what I do sometimes is this breakdown, and it means take all the logs and create me for each trace ID a separate file, and give me please full traces and also this short version of the flow traces. Yeah, now demo will follow. So I will open. I have prepared already the traces here. Yeah. So this is some example of trace file. Yeah. Here we have trace file which already contains processing of some request. Here trace ID start is for the command get groups, and we see that at this point the processing just for this command is ongoing. But if we scroll down, suddenly we see the trace IDs are changing, 73, 75, and imagine if you don't have this information, you don't know what to put together. And we scroll down, and still a lot of different trace IDs are displayed, still scrolling down. Still no response for 74. And now we have again back 74, but not completely. We must be aware that there are some different traces. So the tool now will help us to get these things. So I will call Samba trace parser, and I will ask for trace ID 74. Oh, sorry. And I must provide the name of the directory where the logs are present, or I could even provide just the file name, but it will not include the traces from the children processes. So I will do it like this. And now we have just trace ID 74. We can examine it, or we can see the short version with the flow. This is the full flow. That's quite lengthy, and we have the compact flow. Yeah. There is a question from Volker.
I've seen a flag to say minus merge. One of the problems we had was always that, for example, winbind lookup user group send goes into the child, and you don't see in the main trace of main winbind what happened in the child. This merge in your Samba tool thing or trace parser thing looks promising. Can you merge parent and child, worker child in one output?
Exactly. I will show just now then.
Oh, sorry.
Okay, but I would forget. Thanks you for reminding me. So merge. Thanks. So always we have a notification if the log file is changing. So now there is the main winbinding. Now we see that the processing went to the different children. So we see the domain one. Again, we see the main winbinding. Then there is the AD domain one again. Maybe there will be some more. Let's see. I will next. Yeah, ID map child. So you see all things together. Yeah, and the other thing is what I like to use is this breakdown. And if I list the content group directory, I see for each trace ID 3 files. For example, 66.full. It's the complete traces for the trace ID 66. Then we have this flow. This is the long one, and we have the flow compact one. Yeah. Now I will also. So this is not the right one. I just can't find my slides.
I have one more comment here. For the main winbind, this is not a problem because that's single-threaded, single process. But if you, for example, have 5 or 10 or whatever helper processes all logging into this .ad domain thing, you will get mix-up of different processes under under whatever non-matching debug header lines. And the problem with this is that in many places we are still using debug add, which does individual write v calls. Question, have you seen this in practice on a loaded winbind? Or, I mean, do you have plans to work on this? I mean, this is not rocket science. It's just tedious work going through removing all debug add and replacing them with a single debug.
Yeah, I guess debug add now should also use the same trace ID, so it should be.
Yeah, but the problem is you have different write syscalls from different processes writing into the same log file, and what you need is you need one single write syscall that displays the header line, including the trace ID plus the content. In particular, for the NDR encoded lookup name, whatever structures. And this is right now not the case. So what you would get is one process writes its trace ID line, process writes whatever the first 2 lines of the NDR encoding, then somebody comes in, writes a different trace ID, and then process A continues writing its structure from NDR encoding.
Yeah, exactly.
So we need to make this one write call.
Yeah, because the last write will be messing the debug header. It will appear just as a text which appears to continue to the previous one. Yeah, this should. I remember that this was, I think, your point in my merge request, and I promised to address it in the future. That happened yet. Okay. Yeah. So back to the present.
I mean, so to interrupt, for main winbind is not a problem because that's only single process, single thread. It will become a problem when many processes log into the same log file.
Yeah. Oh no. So. Yeah. This session demo. So there exist man pages. The first there is new smb.conf parameter with name winbind debug traceid. This is by default disabled, and you need to enable it to get both new header fields, traceid and the def. And there is also man page not yet in the master, but will be for the tool Samba trace parser. Yeah, and these are links to the not finished work. So that's the T-when flow support for this tracing the flow and the trace parser merge request.